Okay. I think it's recorded. Alright, so we'll start looking at 3A from 267. That's on the next slide. Alright, 3A. Show that this one simplifies to 2. So, what'd you do first of all?
I distribute, like I FOIL.
Okay. So cosine squared, I'm not going to write all the thetas just for time. So 2 sine theta, cosine theta, plus sine squared. And then the second one, when you FOIL it, you get cosine squared minus 2 sine cosine plus sine squared. Okay?
Oh, I just FOILed wrong then. Because I ended up having that second sine cosine cancel out. And then no matter what I did, I ended up with a sine cosine that I couldn't get rid of.
Oh, okay.
Yeah.
Yeah, if you FOIL correctly, that cancels with that, and then that's 1, and that's 1, so it equals 2.
Thank you.
Okay, Vicky?
B and C for 3.
B and C? Okay. Alright, B, you should have FOILed these two out as well, right?
Yeah.
So what did you get when you FOILed?
I wasn't really sure, but 2 sine squared plus 12 sine times cosine.
Okay, I think that's, when you do 2 sine times 2 sine, that would be a 4 sine squared.
Oh yeah, because it's 3.
Okay. And those are the little things that sometimes drive you nuts. So
Wait,
let's
isn't
see.
the other one 3 sine though? So it would be 2 sine times 3 sine?
Well, yes. 2 times 3 is 6, and then you get a 2 times 3 again. So that's where we get the 12. And then the 3 times 3, we get the 9 cosine squared. And then this is going to give us a 9 sine squared minus the 12 sine cosine plus 4 cosine squared. Okay, so again, this canceled with this, and you were left with 13 sine squared plus 13 cosine squared.
Times 1.
So factor out a 13, and you get 13. So, okay.
I have a question for our exam. Like, you don't always write you write sine squared and then nothing. No.
That
Do we have to put it?
for your IB exam, I would recommend putting it in just in case you got a real picky grader or something. Okay.
Like an X or something?
So, yeah, I recognize that. That's just,
No.
you know, for sake of writing and time. In a lot of math classes, when you're doing stuff like this and all the angles are the same rather than writing it over and over again, we'll leave it out. But you're right, on the exam, I wouldn't risk it. I would just go ahead and do the extra writing, just to be safe. Alright, then we had C. For this one, you needed to FOIL, and you have 1 plus 1 over cosine minus cosine minus 1, right? Negative cosine times 1 over cosine is a minus 1. So, obviously, we've got the 1 minus 1. We need this to be tangent times sine. Alright? What I would do what I would do with this is go ahead and get a common denominator. So I'd make that cosine squared over cosine. Alright. And really, the reason why I'm doing this, I've never done this problem before, so it's not like I know automatically how to do it. But I noticed that I only want one term. I've got two, so the only way I can put those together is to get a common denominator and add them. Alright, so now I have 1 minus cosine squared over cosine. Alright. And what's 1 minus cosine squared? Sine squared. Okay. So sine squared theta over cosine theta. If I take one of those sines, if I separate those, I have a sine over cosine to get my tangent that I wanted. And I have the sine that I wanted as well, that's left over. Okay? Okay. Any other questions? All right. Questions on any other problems from the first two sections? The 3 through 5 or the number 3? Okay. Did we get to this one yesterday? Or no?
No.
Okay. Let's start with this one just to kind of warm up to it, and then we'll look at some double angles, and that'll finish what I had wanted to finish yesterday. Then we'll get into what I wanted to do today. So thoughts? We want to prove that the left side equals secant.
So you change this to
Cosine.
Alright, that is cosine of A. That's our cofunction identity.
Are we given those?
What?
Are we given those?
No. All you're given is that tangent sine over cosine, sine squared plus cosine squared equals 1, and then you are given all of the double angle formulas. Okay? But the rest of them you gotta know. Alright, so that's good with the sine of 90 minus A equals cosine of A. What about this?
Change tangent to.
Good. If tangent sine over cosine, this is sine squared over cosine, right? Zach?
Then you can multiply the cosine of A times cosine over cosine, which will give you cosine squared over cosine. And when you add those together, you get 1 over cosine.
Exactly. Good. Get a common denominator. Again, I have two terms. I want just one term. So I get a common denominator. Sine squared plus cosine squared is 1 over that cosine, and 1 over cosine equals secant. All right, good. So now we have our double angle formulas. And just as a reminder, since we are given these, I'm going to go ahead and copy this over. Copy. So we have these handy. Alright, so there's our double angle formulas. So we're given sine of alpha equals 3/5 and cosine of alpha is negative 4/5. By the way, if you ever really hate whatever letter they use or whatever, just change it. Okay? So if you don't like writing alphas and you want to just use x's, that's okay.
Put that in our answer, you have to write it down.
Yeah, and your final answer for the IB exam, I'd write it back, but you don't want to write fees or
Yeah.
C's. And sometimes they use some weird Greek letters. So, yes, Evan?
Can we do the inverse sign, or is that not going to
We can't. This is the type of stuff that we would see on a non-calculator portion of either my test or the exam. Okay? So that's why they told you sine and cosine, because sine of 2a is going to be 2 times the sine times the cosine. Alright? So that's 2 sine of alpha times the cosine of alpha. Well, sine of alpha is 3/5. Cosine of alpha is a negative 4/5. So we get a negative 24/25. Alright, does this make sense?
This is the same for me.
Same idea for B, except we would need to use one of these formulas, okay? And actually, in this case, you could use any one of them, because we know sine and cosine. Alright, so if we used 1 minus 2 sine squared, we'd have 1 minus 2 times 3/5 squared. So that's 9/25, that's 18/25 when we multiply it by 2. 1 minus 18/25 would be
Negative 7/5.
positive 7/25.
Oh yeah, yep.
Okay. So, alright, so that was B. Now, just as kind of a side note, one extension of this would be that, okay, now find tangent of 2 alpha. Okay? Well, now that I found sine and cosine, I could divide, and I could get negative 24/5 divided by 7/25 is a negative 24/7. Okay? Or, if we hadn't gotten the cosine even, we could have used this to set up a right triangle. Okay? Now you'd have to do a little bit of thinking. Our initial alpha, sine was positive, cosine was negative. Well, that means we were in the second quadrant, right? And then, when we did 2 alpha, when we doubled the angle, that put us in a quadrant where sine was negative but cosine was positive. So that means that 2 alpha is somewhere down here. Does that make sense? So that being said, excuse me, since sine is negative 24/25, here's our reference angle, here's our negative 24, here's our, let me change colors, 25. This is a 7/24/25 right triangle, right?
Mm-hmm.
So now we could find the sine, cosine, or tangent of 2 alpha. Okay? So that's just kind of an extension beyond what this problem was doing, but this is the kind of stuff that, especially some of the more intermediate to advanced questions in our IB exam would ask. Okay? So Alright, a little bit of language here. When we're asked to find exact values, what does that mean?
No rounding.
What?
Do they want it like in pi form?
Well, if we were getting an angle, then yes, you would leave pi in there, alright? Here we're actually looking for values of trig functions, so
You can't round.
don't round, which means it's either a fraction or you're leaving it in terms of a radical, okay? But don't round anything. They want exact value. You may not be able to simplify as much as you might want, but that's okay. So, also, a little geometry review. What does it mean that alpha is acute? It's less than 90 degrees, okay? It's a first quadrant angle to begin with. Alright, so there's alpha. Okay, so it says,
And the other thing is that because cosine of 2a is still positive, you can assume that's less than 45 degrees. Because otherwise you'd be in the second quadrant when you multiply times 2.
that sounds reasonable, yeah. Yeah. Okay. So here we're kind of using our double angle formulas, but we've got to use them backwards. Okay? Because we're given the value of cosine, we want to figure out what sine is of alpha and what cosine is of alpha. Alright? So give those a shot. See what you can do with them. Okay? Use your identities. See what you can do.
We can use a calculator.
No. What?
One 3/4.
Do A and B.
Go ahead and try both. get for cosine of alpha? I can't hear you. What?
Never mind, I'm wrong. Root 14 over 4.
I have root 7 over
Okay.
I have root 7
Root 14 over 4, root 7 over 4,
root 7 over 8.
Over 8.
root 7 over 8,
Or like the whole thing is.
the whole thing. Any more choices? Okay, let's take a look. We would set, I would use this form of the 2 cosine theta. So this is 3/4. I add 1, so I have now 7/4. And I divide by 2, so that's 7/8 equals cosine squared of theta, right? Because I had to add 1 and then divide by 2. So now when you square root it, this is what you get. On the IB exam, stop there. They don't care about rationalizing your denominators and that kind of stuff. For me, I would like you to rationalize. So what you would do is in your denominator, that would simplify to 2 radical 2, right? Or 2 root 2. And then when you multiply by root 2 over root 2, that gives you a 4. This gives you the 14. So this was correct. This is just the simplified form of that.
So both.
Why don't,
Okay, both are correct.
is it incorrect to multiply just the top and the bottom by root 8 over 8?
No, if you did that, you'd get root 56
over 8.
over 8, but that can be simplified because that's 9 times, or wait, no, 9 times 6. No, that's 54.
14. It's
Oh.
4 times 14. So
4 times 14. Sorry. 4 times 14. So the 4 can be taken out as a 2 root 14 over 8, and that would reduce to that. Okay?
How do you get 7 over 8? You just divided 3 over 4 by 2?
Well, I added 1 first, so that was 7/4.
Oh.
So that's 4/4. Add it, so you get 7/4.
Yes.
Then when you divide by 2, you get 7 over 8. Okay? All right, good. What'd you guys get for sine? Guys, put other stuff away, okay?
1.34.
Exact.
No.
Right? We want exact values, okay? So leave it in terms of radical.
Root 2 over 4.
You got root 2 over 4,
Yeah, that's what I was looking
okay? So here you're taking 3/4, you're subtracting 1 now, so you get negative 1/4. Negative 1/4 equals a negative 2 sine squared. Okay? So when you divide by a negative 2, it's 1/8. And you're taking the square root of 1/8. Which, if you rationalize that, you will get root 2 over 4.
So you get. Oh, if you.
Because that's 2 radical 2, then you multiply by a radical 2 over radical 2, and that makes the denominator 4. Alright, our last 2 here. Use the appropriate double angle formula. Here, this is a good example of taking something we're familiar with, these double angle formulas, and applying them to a situation that's not specifically it's not specifically designed for. Okay? For example, on A here, we have 3 sine cosine. So the question is, well, how do we get, when our double angle formula, we see that sine of 2 theta has a 2 sine cosine.
We'll just solve that out.
You do sine x cosine x plus 2 sine cosine.
You could do that. Alright, do you guys hear what Mia's saying? She's saying split it up into sine cosine plus 2 sine cosine. And then this would be sine 2 theta. This would be still the sine theta plus cosine theta. Is that simpler? I don't know. Okay.
Isn't there an identity for sine times cosine?
Well, 2 sine cosine.
No, sine times cosine.
Well, I know sine times cosine. There's no specific identity for that. For just 1 sine cosine. 2 sine cosine would be sine 2 theta. Alright? So the question here, guys, is, you know, that is one way to quote unquote simplify it. But is there a better way? And I would say there is. But let's look at what we want to get. We want 2 sine theta cosine theta because we want to be able to write it as sine of 2 theta. So how could I rewrite this? What's another way I could rewrite that to get a 2 sine cosine? There we go, alright? If I take this and I multiply it, or really I'm factoring out a 3/2, if you think about it, what would I have to multiply 2 by in order to get 3? Well, 3/2. Okay? So 3/2 times 2 sine cosine is 3 sine cosine. So now I can change this to my sine 2 theta, and it's just multiplied by 3/2. So, again, we're adapting a situation to be able to use a formula that's not specifically designed for that situation. Okay? Oops. Any questions about what we did here? Alright, last one.
But where is the second part? It's supposed to be a 2 sine cosine times sine over sine cosine.
What do you mean?
Like at the beginning, we wrote the sine times cosine in parentheses, and then 2 sine times cosine. Where is cosine?
Where does cosine go?
Yeah, where is?
That's just in the identity.
No. Okay, never mind.
We just did this 2 different ways.
Oh, okay.
The first time, Mia had said,
Also,
hey,
it's 2 different ways.
yeah, I showed you 2 different ways. The first way we did it, you couldn't really go very far with it. But this way, we were able to. So. Alright, how about B? What do you think about this one? We see a cosine of 2b here. Cosine squared of 2b. What? Into what? No, it's a good idea.
A difference of
two squares, so you could do like 2 cosine 2b. Wait, no, never mind.
Okay, and you could, but then you'd have plus radical 2 and minus radical 2.
Could you do 2 times cosine squared minus 2? No, minus 1? Because that's the infinity.
To do this, 2 cosine,
No, not 2. Oh, yeah.
if we factor out a 2. Now, here's the thing, don't try to factor the 2 out of here, because that's inside. That's inside the cosine function, so you can't, it's not cosine times 2b, so you can't factor it out, it's cosine of 2b. But actually, that is where we want to start, okay? Now look at this, alright? This says 2 times the cosine squared of some angle minus 1 equals cosine of double whatever that angle is, right? We're finding the angle of 2b.
Can't you just say that that's cosine of 4b?
Yes, okay? Double this is cosine of 4b.
Times 2.
Alright, and then, yeah, we have this 2 still here.
What about square?
Okay.
Power.
Here's the thing, just because we already see a 2 here doesn't change the fact that this is just some angle. And this just has to be double whatever that is. So if this happens to be a 2b, I can double it and get 4b. Does that make sense? Okay. It's kind of like a substitution. I'm going to let theta equal 2b. Okay? So really what I have here, I have 2 times 2 cosine squared of theta minus 1, right?
Theta, and in this case is 2b, right?
Yeah, I just substituted it in. Okay? So, according to this, that equals cosine of 2 theta. Right? So now let's put the 2b back in. 2 cosine of 2 times 2b is 2 cosine of 4b. Okay?
But
So-
what about square? How will you get rid of power of square?
Just by using the identity. The identity says this squared
Equals.
equals that. Okay. Alright? So you have to get a little creative and flexible with these. This is one thing. Yes, the IB does not require you to memorize as much, but it does expect you to be able to apply those things that they give you to a wide variety of situations. Okay? So in a sense, it's almost more challenging because, yeah, I'm not having to memorize, but there's a lot more problem solving. Okay? So. Alrighty. So that's everything I wanted to finish. Alright, we're doing okay. And tomorrow is scheduled for like a wrap-up day and review, so we'll be okay. We'll get you guys caught up. We just won't be able to review quite as much, but that'll be alright. So let's take a look at what I want to do today. Really, it's just a matter of solving some more complex trig equations. We've kind of come full circle now. If you remember on Monday, the first thing or actually not Monday, Monday of last week, the first thing we started with was solving the basic trig equations and using those reference angles to solve them, okay? So now we're doing that, but we're incorporating situations where we have some of these mixtures of trig functions, and we're gonna have to use identities to be able to solve them, okay? So, we'll start with one here. Notice we're in degrees, okay? So, let's think this through. How would you go about trying to solve the equation here? We have sine squared of theta equals 3 cosine squared theta.
You can change sine squared to 1 minus cosine squared.
Okay. Okay. It's a good thought. So now what do we have?
Could you do something with the 1?
Like what?
I don't even know if I'm doing it.
Well, just simplify it, just add cosine to both sides,
Yeah, okay.
make it a little easier.
Can you do that?
Yeah. This is not a proof, we're actually solving an equation for theta now. Okay? Yeah, we're not proving anything now, we're solving for what angle would make this true. Because this isn't always true.
Divide by 4.
So we divide by 4, so we have 1/4 over here. Okay,
Third.
and we square root. So, cosine of theta equals the square root of 1/4, which is a half. Alright, and it is plus or minus a half. Okay? So, how many answers are we going to get here? We'll get 4. The positive 1/2 will give us 2 of our answers, the negative 1/2 will give us our other 2. Okay?
Is that always supposed to happen when the curve says?
Yes.
How have I never seen that before?
Well, if you remember back, to your beginning algebra, if you had x squared
Yeah,
equals
no.
9, it was always plus or minus 3.
I just don't remember doing it last year. It seems like it'd be a fairly common thing. I don't know.
You may have solved this one a little bit differently too. I mean, 'cause there is more than one way to solve this, but
An easier way to solve this?
the only other way that I could think of quickly would be to divide everything at the beginning by cosine squared, and you got tangent squared equals 3. So tangent would equal radical 3, and then you've got to kind of think about your unit circle a little more. What has a tangent of radical 3? So you're kind of doing sine over cosine and a bunch of those. Right? So, sticking with the sines and cosines when you can might actually be easier. So where does cosine have or where is cosine equal to 1/2?
60 degrees.
Okay, 60. And where else is it positive 1/2?
300.
At 300, good. And then, how about negative 1/2?
120 and 240.
Good, 120 in the second quadrant, 240 in the third quadrant. Okay? So there's our 4 answers. Alright, not too bad, huh? And by the way, this is one you might see on a non-calculator part, because you can use your unit circle to figure out all your answers. Okay? Alright. This one might look vaguely familiar. Do you remember what sine times tangent plus sine of 90 minus theta simplified to? It was secant, right? We just did that identity So this is a good example from our previous lesson. This simplifies down to secant theta equals 2. By the way, this is a great example of one where you might see a hence. The first part of the problem, they might say, show that this equals secant of theta, and then they'll say, hence, solve this equation. There might be another way of solving this equation, but they want you to use this substitution. Does that make sense?
So like on your test, you
How did you get
instead just give us this one rather than the other one, because this one has more concepts.
Or I would give it to you in a two-part and say, hence, do this. And the nice thing about those, it may seem annoying that you have to use their method, but that's one thing. If I just gave you this and you couldn't figure out how to simplify it, you'd be stuck. But if I said, hey, first of all, show that this equals secant, if you can't figure out how to do that first part, you could at least say, okay, well, I don't know how, but this equals secant, so now I can at least do the rest of the problem. And that's kind of why they give you those. They're testing two different things all in the same problem, but they're kind of giving you the intermediate part so you don't miss out on the whole thing. Mm-hmm.
Say like on a test, I don't know if you would do this or if you would do this, but like we had, the test was kind of like what we did today, so how we had that problem earlier on,
Mhm.
and then a step problem was this, would you want us to show all of our steps to how we got secant theta again or no?
No, you could just say, you know, by number 2, we get here, or
Okay.
something. I mean,
And same with IBSL.
if you already did the work, don't do it again. Yeah. So. Alright, so,
It has the exact same solution as the last problem.
okay, this is 1 over cosine, right? So, that means that cosine equals 1/2. This one only has half the solutions of the last one.
Because it's not plus or minus.
Because it's not plus or minus, so what solutions do we have?
60 and 300.
60 and 300, good. Well, not equals. And, okay. Okay. Alright. Would someone like to try this one? You can explain it to the class.
Is that correct?
It's not too bad.
So you want to get one thing, so like you have secant, tangent, switch everything to cosine and sine.
You could, or
Is there an identity?
I see a secant squared.
Oh, there's an identity with tangent and secant.
It's
No,
tangent
that's
squared
tangent
minus
squared
1 plus
plus
1.
1.
Good. Tangent squared plus 1 equals secant squared. So I would start by substituting that in.
But what about 3?
You put the 3 outside?
Yeah.
Or is it 3 plus 3 tangent squared plus 3?
Well, once you distribute, yes. Okay. So take it from there. What do we want to do?
If you want to get one thing.
Divided by 3?
You could. I'd rather distribute the 3, honestly. That way I'm not having to mess with fractions. You'll get the same answer either way, but.
Should we write on the board?
Sure, you want to put it up there?
Yeah, that was weird.
Is it
Yeah.
calibration just an arrow? Alright.
What was the answer then?
This one you have to, it's 5 plus tangent theta. On this one, guys, you're gonna have to treat it like a quadratic okay? So, we'll pick up there tomorrow, finish it off, and go from there.